Hello everyone, welcome to our presentation. The topic is SaaS, it's called Software as a Service, and your presenters are Nidish Nair and Avinash Mysore. SaaS as an idea has existed for many years now. However, in our presentation, we will be considering the modern idea of SaaS, i.e. what the industry thinks of SaaS now, and in which direction it sees it going. Just a word of caution, we'll be using the words consumer and user quite interchangeably. In case there comes a point where they are differentiated, we'll make sure to emphasize on it. Now we found this good picture that explains the obvious differences between SaaS and its predecessors. The client server has a single provider serving a single customer. The ASP is more enterprise or industry focused, which caters to users having individual or unique needs. SaaS finally is a concise and better update of ASP by holding data on a single server having multiple clients. Now, initial attempts of software delivery through internet have commonalities with on-premise applications, namely licensing and architecture related. Since they were built as single tenant and data and process sharing was not a major requirement in them, and hence monetary gains achieved compared to the locally installed counterpart was far lesser. Now, as we all know, as years have passed by, users' demands have gone up at higher rates, and technology can barely keep up with it. The CS, that is a client server, and the ASP models thereby seem outdated, owing to the increasing demand for better and more cost-effective version of any service that a user needs. Now, in the coming slides, we have features of SaaS listed out. SaaS is basically all about subscription. It empowers users with lesser hardware needs and low self-maintenance. Now, SaaS applications are expected to take advantage of benefits of centralization through a single instance, multi-tenant architecture, and to provide an experience with lots of features competitive with the comparable on-premise ones out there. A typical SaaS application is usually offered either directly by a vendor or by an intermediary party called an aggregator. The aggregator, as the name suggests, would be someone who bundles SaaS offerings from different vendors and offers them as a part of a unified application platform. It also allows for anywhere, anytime usage, provided you have internet access. There are SaaS providers out there that actually provide environmentally friendly software and services. Sustainable Minds is one such provider. I would recommend anyone who is interested in eco-friendly solutions to check out the SaaS providers out there. The last two slides focused on the relative benefits and advantages of SaaS for users. So this slide basically shows its uses for the providers, namely steady revenue, ownership of privacy, etc. In SaaS, the provider hosts the application along with the data centrally, sending patches and upgrades to the application transparently. It provides access to the end users over the internet through a browser or smart client application. Vendors can also provide API that expose the application's data and functionality to developers for use in creating composite applications. SaaS does not have a specific implementation. It depends on different factors on provider and user side to determine what the final outlook of the SaaS application actually looks like. It can depend on factors like which industry area it belongs to, type of end user, and so on. In the slides coming up, we'll be seeing ways of differentiating SaaS. Here we see SaaS being differentiated on how the service is provided to the end user, basically depending on their usage. Type 1, it's a customer have their own version of the software, various instances of the same application run on the servers. All users in one organization will connect to a single instance, which itself would be different from any other instance accessed by any other organization. Type 2 is basically a modified version of Type 1, which provides a chance for users to configure their own requirements and needs. In Type 3, it's again a modified on top of Type 2, but however, issues like scalability still exist because database is shared amongst the users. Type 4, here basically the database is separated, so the scalability issue from Type 3 is kind of nullified. Here we see how SaaS can be differentiated based on which industry area. The listed areas like CRM, financial models, trading systems, etc. Many SaaS providers have already taken a monopoly on most of these sectors, thereby making it harder for the newcomers to get established. However, there are still untapped markets and also international markets that are open for SaaS to expand into.
Based on maturity levels, in the following slides you'll be seeing 4 different models. Each of the model is technically better than the previous one, and hence it is at a higher maturity level. This is the first level of SaaS maturity model. In this model, each customer works on his own instance, and all the instances on the host machine are independent of each other, and there is no sharing of data across these instances. Because of this, the architecture is simple and involves less development effort. It offers few of the benefits of a fully mature SaaS solution and costs less. It works out for customers who want service for their simple application and don't want to spend more. This is the second level of SaaS maturity model. It is superior compared to the previous maturity model, as the tenants in this architecture get to share the same code implementation. The service provider meets the customer's needs by providing detailed configuration options that allow customers to change how the application looks and behaves to its users. Despite being identical at the code level, each instance remains isolated from all the others. Moving to a single code base for all of a vendor's customers greatly reduces a SaaS application service requirements, because any changes made to the code base can be easily provided to all of the vendor's customers at once, thereby eliminating the need to upgrade individual customized instances. This is the third level of maturity. Technically, it is better than the previous one, as each user uses the same instance and there is only one instance in the system. Authorization and security policies ensure that each customer's data is kept separate from that of other customers, and from the end user's perspective, there is no indication that the application instance is being shared among multiple tenants. This architecture leads to efficient use of computing resources compared to the second level of maturity. In the next level of maturity, the service provider hosts multiple customers on a load balanced farm of identical instances. This architecture is highly scalable because the number of servers and instances on the back end can be increased or decreased on demand without requiring any architectural changes, and changes or fixes can be integrated with thousands of tenants as easily as with a single tenant.